Hi everyone, this is my tutorial for the alignment practice 2. So first we are doing the pairwise alignment using BLAST. So I already pulled up test 1 and test 2 sequences. So I'll open up the BLAST homepage and it says to scroll down to select global BLAST or global align. So I click here and then normally I think the default puts me at nucleotide, so I switch it normally to protein. And then I'm just going to copy test 1 into the first box and test 2 into the second box. And then align. And normally when I have done this, it brings me only one sequence result with a pretty low score. So a lot of other students were saying that it's probably due to gaps in the sequence. So anyways, this is how I did the answer for number 1. So did the pairwise alignment using BLAST. And then for part 2, I used FASTA in order to search for test 1. So I struggled with this part because we're only able to search with one sequence. So here I searched for test 1 like she said to do, and then submit. But unfortunately, I wasn't really clear on how to do an alignment between test 1 and test 2 and what the score for the alignment would be, because I only ran this test for test 1 and not for a comparison of both. But I did get these results. I looked at the alignments and really could not distinguish where test 2 would be in this, but I did just, in my answer, I just kind of mentioned that I received like 50 alignment results. I think that was how much I got, and then I provided the top score for this one. So I'm not sure if that was correct, but that's how I did it. And then for part 3, run a PRSS test to check whether there's any statistically significant similarities between the two systems or two sequences. So I went to this web page. This one felt a little simpler, so I typed in test 1 and test 2 here. And then I'm gonna just copy and paste them into these boxes. And it seemed like this database pulled up the sequences z-score, score bits, or bit score, and then the e-value. So here's pretty much what I looked at the most, and then I looked at this a little bit as well, but mainly looking at these scores here. So those were the answers that I provided for that one. And so yeah, those are the critical statistical parameters that I found. And then for the fourth part of this question, I went to PubMed and searched for this PMID. And then it brought me to this article. So I know that she mentioned to look through the cited by. So I was going through these just to read about GTP cyclohydrolase 1, and then even when we did the BLAST search for test 1, we found a lot of bacillus as the organism, whereas the test 2 had many different organisms. So we found, I think test 2 was found in bacteria, eukaryotes, and archaea. So I just honestly searched for her name, our professor's name, because I figured that's what she was implying she wanted us to look into. So I did find this article that was authored by her. I read through this a little bit, and then I also just started reading a lot of separate articles about GTP cyclohydrolase 1 and bacillus, and then if there was any relationship between the two. And her question was if there are similarities between those two and if it's biologically relevant. So a few things that I found was that the operon of Bacillus subtilis encodes GTP cyclohydrolase 1. I found that GTP cyclohydrolase 1 is an enzyme that's essential for folic acid biosynthesis, And the DNA binding response regulator, MTRA, of Bacillus subtilis is shown to be the structural gene for GTP cyclohydrolase 1. So there is definitely a relationship between the two. And in one of the studies, I also read that GTP cyclohydrolase 1 activity was detected in crude extracts of Bacillus subtilis. So I did determine that there was a similarity between the two sequences and that they are biologically relevant. So that's what I put for my answers. And just from reading those things, and then it's not just strictly Bacillus subtilis, but that was, I think the function of test one that we looked into as the first sequence and the highest score with the highest e-value. But I did find articles about GTP cyclohydrolase 1 in other organisms of Bacillus as well. So that's all for my tutorial. Thank you guys.